Good evening, everybody. My name is Khyati Rajesh Nayak, and my topic for data science and context presentation is imbalanced data. I chose this topic because it is one of the most common issues faced by data scientists. I hope by the end of the presentation, we will understand what is imbalanced data and how to treat it. So let's start our presentation by understanding what is imbalanced data. Imbalanced data refers to those types of data sets where the target class has an uneven distribution of observation. We can see such practices very often in various disciplines like fraud detection. Let's take an example of insurance claim fraud. Here, the number of cases with fraud would most likely be far lower than number of non-fraud cases. This causes our data to be imbalanced. Other areas we commonly see imbalanced data are anomaly detection, medical diagnosis, facial recognition, and etc. Now, let's see why it is necessary to treat imbalanced data. When the number of one class far exceeds the other, then problems such as accuracy myth and bias arises. Secondly, most machine learning algorithms works best when the number of instances of each class are roughly equal. Hence, it is important to treat imbalanced data. Now we will see how to treat imbalanced data. There are multiple ways to treat imbalanced data, but the following are the most common ways. Let's start with sampling method, which has two types, undersampling and oversampling. In oversampling, we are adding more of the minority class, so it has more effect on the machine learning algorithm. As we can see in the diagram, the minority data, which is class A, has been increased to the level of class B to get better accuracy. Another sampling method is undersampling. Here, we are removing some of the majority class, so it has less effect on machine learning algorithm. As we can appreciate in the diagram, the data from the class A has been reduced to match with class B. Main advantage of undersampling is it has less storage requirements and also it has better runtime for analysis. Less data means business needs less storage and it will take less time to gain valuable insights. Primary disadvantage of undersampling is loss of data. During undersampling, data scientists or machine learning algorithm removes data from majority class. Because of this, scientists can lose potentially important information. Think about the difference in amount of data in minority versus majority classes. The ratio could be as low as 20 is to 1 or as high as million is to 1. Removing enough majority events to make the majority class the same or similar size to the minority class results in the significant loss of data. Other way to treat imbalanced data is algorithmic ensemble techniques. Let's see some of the ensemble methods starting with bagging. Bagging is an ensemble modeling technique which works by randomly assigning k samples out of n samples to a subset with replacement. Bagging can be performed on both regression and classification problems. Bagging increases accuracy and reduces variance, and it reduces the problem of overfitting. Now let's talk about boosting method. It is also an ensemble modeling technique which converts weak learners to strong learners. The idea of boosting is to train weak learners sequentially, each trying to correct its predecessors. There are two techniques majorly used in boosting. They are AdaBoost and gradient boosting. Now coming to AdaBoost. It is called adaptive boosting as the weights are reassigned to each instance with higher weights assigned to incorrectly classified instances. Now talking about gradient boosting. It is one of the variants of ensemble methods where you create multiple weak models and combine them to get better performance as a whole. In gradient boosting, each predictor corrects its predecessor's error. Another method to treat imbalanced data is cost-sensitive training. I won't be diving deep into it because of time constraints. So in summary, in this presentation, we got to know what is imbalanced data, Furthermore, we looked at why it is necessary to treat imbalanced data. Lastly, we looked at some of the methods which can be used by data scientists to tackle the situations on day-to-day basis. As with most things in data science and machine learning algorithms, there is no definitive right approach that works every time. Depending on the on your nature of your data set, distribution of classes, predictors, and models, some of the above mentioned methods will work better than the others. And with that, thank you.